for implicit differentiation. Calculate the derivative of that. Go. Y prime equals. Matt Cornelius, what you got? That's good. Okay. Can I also write it like this? This is going to come into play today. Pretty good with that notation. Okay. It doesn't, this was fine. It's just kind of leading you into using your prior knowledge, right? Why do I write dy dx? Exactly. He said it. Derivative of y with respect to x. The derivative of y is 1. But it's with respect to x, so I have to write dy dx. Okay? If I wanted to be technically and perfectly clear, I could do this. Derivative of x with respect to x. But what is that? 1. So do I need to write it? No. Yeah, I kind of shielded you from that. So far, that's going to come into play today. Okay? You don't need it. Right? We don't need it, right? Okay, so using this today with functions that are not just y equals. Okay. We're moving to functions that might look like this. Can you hear me? I'm all flustered. Stop it. Lose my mind here. Can I move everything to y equals? Pretty sure you can on this one. We can't get this in this format, so we just need to deal with it. Okay. It's called implicit differentiation. And it uses this notation every time we take the derivative of a y. Okay, so what is the derivative of y to the fourth? Okay, you know that's the power, but it's with respect to x. So we have to write dy dx here. Because we just took the derivative of y with respect to x. Okay. What's the derivative of x times y? 2. Let's see, okay, derivative first, right? 1, copy second. Copy first. What's the derivative of y? 1. With dy dx. Yes. It's the same here. You took the derivative of y, you had to write dy dx. I was just shielding you from having to think about it. Now you have to think about it. It can be. It's turned into one tomorrow. What's the derivative of that? So we've just calculated the derivative with respect to x. But this one's a little messy. Sometimes Okay, pre-response question, what do you do? You leave it. You leave it. But if it's a multiple choice, sometimes you're asked to simplify. You know, it might say find dy dx. And you can be a smart aleck and say, hey, it's right there. Okay? But that means solve for dy dx. We want to get it equals just like this one. Because that is a slope, right? So, how do I do that? Yeah. Move everything to the right that does not have a dy dx. But leave these alone. By subtracting x or subtracting 4. We're moving it across the equal sign. So I have we just did like algebra 1. How can I move that? It's a common factor in both terms, right? We'll factor it out. Yeah. Okay. What's left? You have isolate. Hey, somebody might say that. Yeah, I do. You could. No, all it does is, well, dy dx is the slope rise over run, right? For the xy grid, now it would just be x over y. We would change x with respect to y. Basically. Yep. Okay, so we have dy dx here, right? Okay, let's look at another one. By the way, these curves start to get kind of funky. This one right here looks like that. Think about this. We live in a world where things are not always pretty. In fact, most of the time they're not pretty and not symmetric and not organized, right? This might be something you have to deal with. Several of you are looking at engineering. Okay? This is stuff that comes about. So, you're not required to know what these look like. Okay? They're not going to say graph this. No. Everything is done as, calculate the derivative. It's all calculus. Okay, but this one is not. The final, of course. That's the final. You don't need better than that. Usually not. Okay. What is the slope of the tangent line to x squared plus y squared equals 1 at this point? This one's a little bit less messy on the derivative, right? Does anybody know what that shape is? Radius? We also know that edge. A unit circle. Oh, shut up. Last little lightness here. I don't care. So that's what we're looking for, right? So we're there. 1. The equation of the tangent line at that point. Kind of give you a picture. Okay, so we have our point. The nice thing about these ones is we have our point. Yes. Done. This means take the derivative with respect to x. When we actually do it, that's when we write the dy dx. Take it the derivative of y with respect to x. Derivative. Plus, no, and then I don't need to write dx dx. Right? dy? Now I have to write 0. Got the constant derivative down. No, just if you do a y. Okay, now you have two options here. You can solve for dy dx like you did on the last one, and then plug it under z for the slope, or you can plug it in now and solve for dy dx. Doesn't matter. Okay, let's read it out then. What do I end up with, Trevor? Okay? What's my next step? Yeah, take the 2 out. The dy dx is negative x over y. Right, so what's the slope of my tangent? Our tangent. The slope is you plug these numbers in here, you get a value for the slope, right? So dy dx evaluated at this point. Remember that notation? We haven't used it a lot, but it gets used whenever we go throughout the year. So negative 3s over s. So there's that. Negative 3 over 4. Hey, what's the equation? So I dropped from the cup of that so that we have it on here. You're doing that side for me. Really slow. Yep. the same process that we've been working on for 2 or 3 weeks now. You just have that little thing called implicit differentiation. Okay. You're also going to run into where is the tangent line horizontal? Horizontal? Yeah. 0, what? You can see it on the picture, right? How would you figure it out? With that? 0's hooked, right? The horizontal line? Do we have to worry about the denominator? No, we don't. So set x equal to 0. Oh, that's already done. We gotta find y values. Where is the slope of the tangent line undefined? Y0. Yeah, when the denominator is 0. So that would be. So think in those terms. Some of these, I might say, where is the slope of the tangent line 0? Do I need to worry about the denominator? No, just the numerator. So because we have set equal to 0, you might have a little more work to do than that, but that's just the idea. So I just you're gonna get solve for y. Okay, pay attention to this. This could be this is probably going to come up. I'm not going to throw it at you today on the homework, but it will come up. So if I set the top equal to 0, how do I find those points? Because there's an x and y, right? So I have to solve for y. And then I put that in to the original. So this is y, correct? It's a system of equations. So I would take 2x plus 1, and I would put it in right there, and I would solve for x. Then I would give you your x value, correct? And you plug your x value in and calculate the y values. Or you can plug your x value in and calculate the y value. Okay. And then you have your point. Most of the time, right now I'm not going to show you, it's actually with 2 variables here. You would just have it is challenging. When you get good at these, you start to make it simple. Okay. You want to see one more derivative? Here, this one has e. One more, okay. Okay, so take the derivative with respect to x. What's that rule called? Integral. So what's the derivative of p? Copy inside, right? And what's the derivative of x minus y? Derivative of x is 1. Derivative of y is 1 dy dx. Okay. Now let's the right side. Or x dy. Okay. And then if you wanted to, you could solve for dy dx. What? I don't memorize every. I'm not fast. I don't memorize every problem. So you could solve for dy dx. You could find slopes. You could do all sorts of stuff with this. But that's just another derivative calculation. Okay. There are a couple other examples in your book. Okay, if you need to look through them. Okay, give yourself a pat on the back. You've calculated derivatives. That's all the calculation of derivatives that you have to do. You just need to practice those now. Yep. Of course, half of you are going to be here. Come on, man. That is one disappointing fact about not having a green chalkboard. You are black, so I would use it. There you go. Okay, not a lot of new stuff. 6 problems. And the spiraling. Sounds like you're getting a lot better. Okay, thank you. You have the hope. May 5th or whatever the day is of the test. You got 6, 7 months. Think how much better you're going to be at these. Leave the rest out to start on those. Try, ladies and gentlemen. Try to get number 1 done. If you can do number 1, you're on the right track. Why is it here in the picture?
Yeah, see.